Predictability. We take for granted that the world around us is at least a little bit predictable. If there is a table in a room and we turn to face away from it for just a second, we expect the table to still be there when we turn back. If we place an apple on the table, we expect the table to spot it rather than the apple falling right through the floor. As much as we might lament how difficult it is to predict the weather or future election outcomes, we should be impressed by how much reliable predictability there is. Physics is made possible by this predictability. It may not be absolute, but we can somewhat anticipate what's going to come next in the world if we know what's going on right now. The most basic kind of predictability is conservation. The fact that some things don't change at all. Conservation is just how physicists refer to staying constant over time. You may have heard that energy is conserved, for example. Energy isn't a kind of substance like water or dirt. It is a property that things have, depending on what they are and what kind of situation they are in. There is no energy fluid that flows from place to place. There are simply objects that have positions and velocities and other properties, and we can associate a certain amount of energy with them because of those facts. An object can have energy because it is moving, because it is located at a high elevation, because it is hot, because it is massive, because it's electrically charged, or for other reason. Under the right circumstance, those forms of energy can be converted back and forth between each other. The energy that a wine glass has just from being located on a table can, if the glass is knocked off the edge, rapidly be converted into energy of motion as it falls, and then into heat and noise and other forms of dissipated energy as it breaks on the floor. Conservation of energy is simply the idea that the total energy given by adding up all the individual forms remain constant throughout the whole process. Wait, is this circular reasoning? Are we merely inventing a bunch of quantities that add up to a constant number by definition, calling that energy, and congratulating ourselves for discovering a law of physics? No. There is an independent way to define energy and then show that it is conserved, based on the fact that the laws of physics don't themselves change over time. But you are asking the right kind of question. As simple an idea as we can imagine, there is a quantity that doesn't change. It stays the same as time passes. But conservation of energy and other quantities isn't just a gentle, unintimidating place from which to launch a survey of all of physics. It is logically the right place, since an understanding of conservation was the first step in the transition from pre-modern to modern science.